Alright, we're up and streaming. Alright, welcome everyone. Episode 9, repair number 8, I guess. This is actually going to be a video on what to look for when you're checking a SUB-10, SUB-12, or an RPW amp. They're all very similar amps. We're going to go over what to look for on this amp and how to test it and adjust it if you do a repair on it. So this is the same amp that I previously worked on. We did the restoration on the amp board. We repaired a few flaws on it, and now it's time to test it and to tune it, I guess you would say. So we'll go through it step by step because I've promised a few people that I would do this, and I think it's a valuable piece of information that we need to get out there. So we already know that the amp power's on. Nothing smokes, nothing fries when we turn it on. But I'm going to show you some of the things to go through when you're checking to make sure that you did the repair properly. So I'm going to throw my meter in voltage mode. And I have it hooked up to the current limited supply, so I'm going to turn that supply on. Here we go. Kill that light a little bit so it's not blinding me. Alright, current limited supply is on. Not quite sure why there's a MOSFET on my bench here, but okay, cool. Play with that later. So power's on. So the first thing I'm going to just check is, and I'm not going to touch anything in here, so be careful when you're using your probes. Like, reach over things. Don't lean your hands inside the amp. Let the probes do the checking for you. So I'm going to check the voltage regulators, and it doesn't matter which polarity you check them in. I just want to make sure that we're getting like 25 to 30 volts. So right now we're showing negative 27. And then we can flip it around the right way if you really want to. But this is the easiest way to check to make sure that the power supply is working from this, or I'm sorry, from this side going back. So we know that, we're getting power coming out of the transformer. That means we know that the PDC board over here is good, and we know that the two MOSFETs are good. So, alright, so we got that far. The next place that you're going to want to check is the output of these two resistors here, and we're going to check them on the two legs on this side. Not back here, we want to check it up here. So we're going to carefully grab each leg and measure it, and what you want to look for is about 5 volts. So we're at 5.3. So 5.3 volts with the volume all the way down, or close to all the way down. That lets me know that the dashboard is functioning properly. So if you're getting 5 volts out of there, you're doing good. Now, one thing that you might want to check is how hot these guys get. Sometimes when this board fails, it will turn the transistor on, and these things will get screaming hot. I've seen them actually burn a hole through the board before. So if you're unsure of the repair that you've done, flip the switch on, check them, kind of quickly, see if they're getting hot. If they're getting screaming hot, you still have a problem over in this section of the board. If they don't get hot, and if you have 5 volts coming out of them, then you know that section is good. So we verified that all the power supplies are working. We don't really need to check the feed to those. If we're getting 5 volts over here, even if we're not getting 5 volts, chances are that the 100 volts is getting into the dashboard, because we have the voltage over here at 25. So if we're getting voltage here, chances are that this transformer is also feeding this part of the circuit. It's possible you could have a burned out winding. Extremely rare. I haven't found one yet. So we know that our power supplies are good. So I'm going to power it down. I am going to hook up a speaker, or in my case, my 2 resistors. And we're just going to simulate a load going out. Yeah, alright. So I have my good scope hooked up. I'll try again with the cheap scope, but when I was testing that earlier, I was not getting a good visual indicator on the cheap scope. This might be something that you need a good scope for. So I'm clipping my meter probes across the resistor, basically what it would be like clipped across a speaker. And I'm going to give it an input. I generally like to use 100 Hertz. Just shows up a little bit better on the waveform. So, and I use both left and right. You don't have to use both left and right. So I have the low pass turned all the way up. The volume is almost all the way down. Auto on is turned to on, and the phasing doesn't matter. I have it at 0 right now. So set the amp down. Be careful that you don't crush your RCA plugs. And we're still going to run in current limited mode. So I have power applied, and now I'm slowly going to give it some volume until it shows up on my scope. And oh, we need to be at 100 Hertz. I'm at 40 Hertz right now. Let's try that again. 50, 60, 80, 100 Hertz. And it will go into current limiting mode if you give it too much volume. I guess for the sake of this test, and it's doing that because I have the speaker hooked up, but let's do it without the speaker hooked up and with. Actually, I'm going to leave it in there for now. I'll just go to full power, and I will crank it up till I have a signal on the scope. And I'm going to show you this in a second. Alright, so we have, I don't know, we're probably at about 50% volume. And I don't want to keep this on too long because it's definitely going to be pumping into my load here. So here's my scope, and you can see we have a pretty nice 100 Hertz signal on there. Now what I'm going to do is I'm going to adjust these pots on here. And of course I don't have the right screwdriver. Why would I have that out? There we go. So I'm going to show you what to look for. So I did have to replace this adjustment pot that you can't see because I'm blocking it on the screen. I did have to replace this guy here. When I took the glue off, it was not functional. So make sure you check your pots. Alright, let's go back to the waveform. So I'm going to take it out of tune, and hopefully we'll be able to see the change. And it's not behaving, probably because I have it into a resistor. It's very, very minimal. Alright, so let me turn this down. Let me disconnect the load. Shut your power off first. A pure resistive load does not simulate a speaker because there's no back EMF. But it's going to be incredibly hard to show you guys what I'm trying to do unless you can visualize it. So you have to be able to see it. It doesn't matter which way you hook up your probes. They are a pain in the butt to get through these little holes on here. These are just cheap Amazon probes, or test clips, or whatever the heck you want to call them. Alright, we're back in. We will go to current limited because we don't need the power output, and we will generate some volume. Alright, so I'm going to adjust these now. You can see on the bottom part of the waveform, right down here on the bottom that it's getting kind of noisy and nasty. And I'm turning the pot counterclockwise, so I'm going to slowly start turning it clockwise, and you're going to see that that's going to disappear. And I'm going to keep going. And with my current limited supply, let me pan over to the light really quick so you guys can see this. We'll make that a little bit smaller. Zoom out, and let's go over to my light bulb over here. So if you watch the light bulb, as I start to tune this and take that noise out, you're going to notice the bulb's going to start getting brighter. So I try to tune it until the bulb stays dim, and I get rid of as much of that noise on the scope as possible. And that'll keep the heating in your outputs down. So I found that when you have your bulb glowing, obviously you're passing a lot of current through, and your outputs just get screaming hot. Now, you can take it like right to the edge where it's glowing a little bit. I don't really know what the value to set these is. They don't provide that information. It'd be really nice if we had, you know, some values to actually adjust it to, but this is kind of just guesswork. But this is what works for me, so if it works for me, it'll probably work for you. So I'm going to do the same thing on the other side, and we're going to, you know, it's detuned right now, and we're just going to try and get as much of the noise out as possible. And then we're going to keep an eye on that bulb and just, you know, either go for a very, very dull glow or no glow at all. You're definitely safe going with no glow. And you could see the top of the waveform cleaned itself right up. So we'll go back to noisy. And there's a delay because I'm running my scope through Ethernet because it has to be isolated. But you can see the top of the waveform is got a little bit of noise on it, even though the response is slow. And then as I start to tune it out, it gets better and better and better, and then I start to go to a very small like glow on my bulb. So right there I'm going to say that's good. And you know, we're tuning a subwoofer, we're not tuning mids, we're not tuning highs. Like, subwoofers make noise. They don't really make you know, audible frequencies that need to be like 100% crystal clear. Like, the distortion is going to be higher in your lower frequencies than it would be for your mid-range. So unless you want to be OCD about it, I really don't see, you know, a reason to do so. So that's what we're looking for. And you know, we can change the frequency. We can go down, widen up the wave a little bit, or if you want to, you can, you know, compress it down and go to something really high. You know, there's let's go up to 200 hertz, and you'll notice as you go higher in frequency, you start to lose amplitude, and that's because you're starting to hit the crossover frequencies. So you won't be able to compress it too much, but you can definitely widen it out. So I'll take it down to 30 hertz, and you know, you can tune it at whatever frequency you really like. I prefer 100 hertz. I think it gives the best view of the actual wave, and it's still well within the operating range. But you know, whatever works best for you and the equipment that you have. Now, I will switch it over to the cheap scope, and we'll have a look and see how that works. And it will show up actually better if you have it hooked to a speaker. And let me here, let me just plug my speaker in, turn the volume down, and hook up my one speaker. It's not what time? It's only 10:30. The wife can't kill me yet. So we're going to turn our volume down. We're going to turn our power off. And I'll show you what it looks like hooked up to a speaker. And everyone's going to behave a little bit differently, so keep that in mind too. You're looking for tuning out like the disturbance in the sound wave. You're not looking for exactly, you know, what I have. Yours is probably going to look different. So be prepared for that if you're doing this. It will not look exactly the same as mine. If it does, you got lucky. Alright, we got the speaker hooked up. Make sure we're clear. We're going current limited again. Right now I'm at 42 hertz, so I'm going to crank that back up to 100. And you saw when I panned the camera over, I'm not using like fancy equipment. That signal generator I got on Amazon, and I 3D printed the housing for it, so. We're hitting current limit already, so we'll go full power. And I am going to zoom in. That is not the waveform that I see. I might have to restart the scope software, it might have froze. Let's see what happens there. Run. Bear with me. Yeah, I'm not getting a waveform update. Alright, hold on. Let me restart this software. It's one of the things about buying a cheapy scope. It doesn't come with the best software. But it works great when you're looking at the screen. Like, I don't really expect the software to be flawless. There we go. Try again. I'm going to introduce that disturbance again. Okay, you can kind of see it. I'm going to widen the waveform out. And let me lower. So it's hard to see, but you can see that in the center of where the sine wave is rising up, there's a vertical spike in there. And it looks way better on my scope than it does on the screen, just because it can't update. But that spike is the noise that we're tuning out. So I'm just going to tune it until I have a nice straight line. And it's nice and clean. Alright, let's see if I can do that again. Alright, there we go. We have one cycle on the screen. Let me see if I can introduce that line again. So you can kind of see it. It's really hard to see on the software, but you can kind of see the spike, and it's happening. If you can see the mouse where I'm moving it. Nope, can't see the mouse. Damn it. Alright, well, if you look right in between where it crosses 0 on the sine wave, there's a vertical spike on there. And you'll see it on your screen when you're doing this, but you're tuning out that spike. So when you have the speaker hooked up, you know, it does look a little different, but you can still do it with the speaker hooked up. It's not something you can hear. The audible tone does not change at all. But again, we're just adjusting the two pots here to control. I guess that changes the crossover point between the two sine waves, because I don't understand how the circuit works fully, but you have a wave that, you know, you have part of the wave that goes up, and then you have part of the wave that goes down. And one set of the amplifiers just does the up sides of the wave, and the other side does the down sides. So where those two meet in the middle, you know, coming down, you have the one sine wave tapering off when it hits 0, and then you have the other one that goes negative, and it goes down and back up to 0. So these adjust the phasing in between those two halves of the amplifier. And when you change any of these outputs here, you have to adjust those. I mean, I guess you don't have to, but if you want the best sound and you want the most efficiency out of the amp with not throwing out a bunch of heat, you need to adjust those. Let's see what this looks like. We're going to hook it back into the load, and we'll try and see what we can see on the little baby scope. So I'm going to turn the volume down, turn the power off, close out of my scope here. And I hope you guys were able to see that. I know that you know, that software doesn't really have the highest refresh rate, so you can't really see it in real time. It looked a heck of a lot better on the screen of the actual scope. I'm sure that's because it's the amount of points that thing's trying to transmit over the Ethernet. It's just a lot of data. Either that or the software's garbage, one of the two. Alright, well, we can see this. I am going to turn off the data, if I can remember how to do that. I think it's the OK button, push and hold. Yes. And I will put it back on. We'll go right to full power. And here's our wave. And we can see it. So I'm going to look, you know, somewhere right in the middle of the wave. And I'm going to try and introduce that little, yeah, that, I don't think this guy's going to pick it up, to be honest. You need a scope with higher resolution, unfortunately. I don't think this one just doesn't have the bandwidth to, you know, maybe you can see a little something there, but I don't think it's enough to be able to tune it. Let's see if we can zoom in on that. See if we can widen it out. Yeah, the cheap scope just ain't gonna do it. It does not have the I mean, I'm seeing a little bit of the spike there, but it doesn't have the storage or the resolution to pick up something that small. So I guess if you don't have a good oscilloscope, the light bulb would be the next best way to do it. So you take your adjustments and you tune them until you get the glow on the bulb, and then you back it off until the glow goes away. That would be the next best way to do it. And I will do it by eye with the light bulb here, and then I'll look at the scope and see where we're at. So I'm adjusting it. And alright, now I'm just starting to get like a really, really dull orange glow. And this would be even better if I had a clear bulb, but I don't have a clear light bulb right now. But I have a very kind of faint glow. I'm going to back it down just a tiny little bit, and yeah, look in the scope and any of the disturbance is gone. So that's how you adjust the bias on it. So let's turn the volume down and disconnect the speaker. And then put it back into the resistive load, and then I can crank it up a little bit. And I mean, it's already getting mildly warm. But that is that's basically how you do it. You don't need really anything fancy. It helps to have a scope. You can really get it dialed in better with a scope, but I would say it's not required. You can use a dim bulb test to get somewhat the same results. That's how I've been doing it. There may be better ways to do it. The way that I'm doing it might be wrong, but it seems to work out okay. I haven't had any complaints, and I really haven't had any problems doing it this way. So that is how I do it. So I know this is a quick one. I appreciate everybody tuning in. Hopefully you guys can get a little bit better understanding of how to test these things to make sure that the repair is successful, and then get it tuned in so it'll sound good and it won't overheat on you. I hope this answers some of the questions that you guys have had. I'm gonna get into a repair tonight. It's still pretty early. I have 3 that I have to get through. I'm not gonna get through 3 tonight. Hopefully, maybe we'll get through 1 tonight. So I'm gonna go grab a fresh coffee, and I will be back in a little bit. So thanks for tuning in. Remember to like and subscribe. If I helped you out, follow me on the Klipsch forums. I'm also on the Carver site, which are the Sunfire forums now. I'm gonna start doing some more Sunfire stuff and mix it in with the Klipsch. Whatever comes in that somebody needs repaired, I'm gonna do a video on, and if there's a forum for that group, I'll register and start posting on those forums. So I will see you guys in a little bit. Thank you.